It is given that a flat plate of area 20 centimeters square is separated from a large plate by a layer of glycerin of 2 millimeter thick. If the coefficient of viscosity of glycerin is 20 poise, the force required to keep the plate moving with a velocity of 2 centimeter per second is. So over here we are considering that there are two flat plates. So take it as one plate is like this and the other plate is over here. And in between these two plates there is some fluid. So we are exerting, and when assume that we are trying to displace this upper block relative to the lower block, then as it is moving towards right, this liquid will exert some frictional force or viscous force. So if you'd like to move it with a constant velocity, then we need to exert the same force in the opposite direction, so that net force will be equal to 0 and particle will move with the plate will move with a constant velocity without any acceleration. So we can just use that equation. The value of viscous force will be equal to this the external force. So we know the equation for viscous force is equal to eta into A into dV divided by dx. Over here the value of eta is given as nothing but 20 poise, and poise is unit of viscosity in CGS system, and answer is also given in CGS system, that is in dyne. So we can take it as it is 20, and area of plate is given as nothing but 20 centimeters square, and this plate is moving with the velocity which is given as nothing but 2 centimeter per second. So we can write velocity of this layer of liquid which is in contact with the solid will be equal to nothing but 2, and the layer of liquid which is in contact with this plate will be at rest. So the difference in velocity between these two layers will be equal to 2. So dv is dv by dx is velocity gradient, change in velocity with respect to distance, which is 2 minus 0, 2. And distance between them is given as nothing but 2 millimeter. So dx we can take it as 2 millimeters. We need to convert it into centimeters. So we can write 2 into 10 raised to minus 1 centimeter. So we can find out the value of this viscous force over here. So this 2 and this 2 get cancelled. So we can write this is equal to 220 into 20, that is 400. And 10 raised to minus 1, when it is coming to the numerator, it becomes 10 raised to plus 1 or 100. So we can write the final answer will be equal to 4000 dyne.